Okay, so welcome everyone. Our presenter, Dr. Armando Falcon-Brindis, is already with us here. As you can see him, he is an assistant professor of entomology at the University of Idaho. His research combines pest management, ecology, and sustainable agricultural practices. His extension program focused on educating people about IPM, pollination, and agricultural, pest, and beneficial. He has published multiple scientific articles, journals, presented over 90 talks in different countries. When he's not working, he loves drawing, hiking, playing soccer, or his guitar. So he's in Idaho and a lot of hikes like Utah. So um, with that, again, I welcome all of you. With that, it's all over to you, Armando. You are
All
muted.
right.
So
Yes. Thank you, Chito. Okay, I will share my screen. Okay. Thank you for having me here. I don't need to introduce myself since you did it. So today I'm gonna be talking about pollinator protection in arid western landscapes, and of course I'll be focusing on a few cases that we have specifically in our area in Idaho. But this is the overview of what we'll be talking today. I'm going to talk about global and regional trends and concerns. I really want to give you this background information so we are aware of what's going on and why we do pollinator research and extension. And then I'll talk about plant pollinator interactions, and then pollinator protection in the Pacific Northwest, and then the take-home messages. So as I mentioned, these are the global and regional trends or concerns right now. Um, Actually, I don't know if you are aware of this massive decline of insects, and it's actually a defaunation. Actually, this is not only with insects, but I want to highlight this first, that there are multiple publications, people from different countries raising their voices and saying, hey, we're losing insects. And this, some people call it different names, collapse, apocalypse, and but it's all related to, it's in response to something called defaunation in the current era that we are, the Anthropocene, right? So according to this publication from Rodolfo Dirso, uh, they found, this is a meta-analysis, right? They found that on Earth, we've lost 322 terrestrial vertebrates already since since the 1500, right? So no more of that. But if we ask, hey, what about insects? So it will depend on the insect group, but also you could see you can see that pretty much everything is declining. So I would say hortopterans, grasshoppers are the most affected probably, but here's also another, like the global index, and it's pretty much all the invertebrates who have been undergoing these extinctions or declines, all the populations. And they put an example of Lepidoptera out there, if you can see that. So it's kind of dramatic. That's not the only one, of course. That's not the only, or the only publication. That was one of the baselines, the people who raised those concerns. But after that, a lot of other things came up, and we continue to do research towards understanding why are those declines? Is that a generalized thing? Because I said that these were meta-analysis, but what about particular cases? What about more regional scales or local scales? What about different groups and specific times and locations? And it's especially, what do we do now that we're losing insects? How do we come back and try to restore habitats. So there are lots and lots of resources if you want to know more about this. Um, but in general, we have both terrestrial or aquatic insects. And the estimates say that between 10 and 40% of insects will face extinction over the next few decades. So that is quite a bit. And it can be chaotic if we lose our insects, no matter if it's 10% or 40%, or if it's 1%, to be honest. And we are trying to, conduct research and predict what's going to happen, but it's tough. There are some efforts towards that too. And I put that, just to have in mind, keep in mind what is the proportion of insects and how important that insects in nature. So we have our 8 million plant and animal species. We combine animals and plants and all the vertebrates, right? And invertebrates. We have 8 million species, that known species in this planet. 75% of those species are insects. So we need to know what's going on. And that's why, like I mentioned, people have been trying to to map that out as well and see which groups are suffering more and are more vulnerable to this, for multiple impacts or effects. For example, here in this plot here, on the top right, I am putting habitat change, pollution, biological traits, and climate change. Those are the main ones, but you see the habitat change or habitat, the disturbance is probably the most, with the highest negative effects. The more you can see here, the number of reports, and then the different groups, different taxa. Then also the data has a lot to do because not all the countries have information, right? And everything, or pretty much, or 90% or 80% of the data comes from, the Western Europe and from the US. So we have a lot to do here. Um, these are also like the top factors in general affecting, killing insects or threatening insects. We're not going to go through all of them. I'm just presenting and showing that other publications have, emphasized what are those factors in, disrupting insect populations. So we have, even fires and climate change, pretty much global warming, droughts. Um, these are some issues specifically on the Western. I wanted to emphasize one of them, or look at one factor just as an example. And here the wildfires. So if you live in the West, you know what I'm talking about. So this can be pretty rough, and the problem is that there are more wildfires. They are increasing in number, and also the severity, right, and the length of those have been increasing as well. So it's pretty concerning. So of course we are in a dry region. You see pretty much all the risk it's over here in the Western US. This is another map, another resource that you can look at. It's actually when you click on each little flame, you will see what was the area, the surface that was covered, contained or not. So, but I also want to use this map to point out that the Western US is not only a magnet for wildfires because of vegetation, because of the weather. I mean, you name it, there's multiple factors, and it's been like that historically. I'm not trying to make more drama on this, but there's a fact that the Western US is also harboring more bee diversity. And this is one example. These are the bumblebees. So in this region, including Idaho, Utah, of course, and we have it could be considered one of the hotspots of bumblebees, right? As you can see, between 23, 25 species in some regions. But in general, Western US, right, and Northern Mexico are considered hotspots of bee biodiversity, bee richness globally. So that's also something that I want to put in context so you know um, what's happening, right? And what are we facing? Like I mentioned, it's not like I want to create drama that Western is we're getting more wildfires, blah blah blah. But this is happening, I mean, worldwide. And I found this publication saying that actually we're getting more and more wildfires and throughout the world, and they're more frequent and they last longer. So other other factors, um, like I believe at this point a lot of people know and everyone knows what are those factors when we think about pollution, urbanization, introduced species, uh, increasing ag, surface deforestation, and insecticides. I think that's pretty well known at this point. And but I also want to mention that there's an intrinsic um, vulnerability, depending on which species you're talking about, but there could be an intrinsic vulnerability or habitat restriction because um, that species, for example, in this case, bumblebee, I believe a lot of people know or are aware that this is only found in Southern Oregon, in Northern California. It's critically endangered. And it's because this species evolved to be, or to be adapted to those conditions. So this is another example, right? It's a limited distribution in Sri Lankan southern southern India. You find these cases there are many cases like this, like islands and insects living in islands. They they will suffer the consequences easier compared to others. If we think about all the effects that I just mentioned, that's why these species are critically endangered. But that's not all. At this point, we have over 600 species of insects, right, in under vulnerable category. We have over 400 species endangered, over 200 critically endangered. Almost half of that are orthopteran, I mean grasshoppers. And in total, we've lost, believe it or not, 58 species. And probably these are the ones that we know, right, that we are aware of. A lot of that are lepidopterans. So we lost those species forever. And I put this a publication was in the news saying that butterflies can provide an extraordinary help to pollinating cotton fields. So I'm trying to link that information with our, our need to produce food, our needs in agriculture. So we're losing insects, but they're helping us, and we are starting to realize that more and more. I want to talk about the plant-pollinator interactions, but at a very basic level. So we understand that we have specialist and generalist insects, or we call them flower visitors, right? And within that community, we'll have, of course, multiple species of butterflies, bees, flies, wasps, moths, um, beetles, and they rely on multiple flower or floral resources, Okay, what do they get out of this, of that? I mean, we typically think about just the nectar, but they also get, especially bees, they need the protein, they need the pollen. So it's easy to think with this visual aid, it's easy to think that if we start losing plant species, the plant diversity, we're going to start losing pollinators because they won't be able to find the protein and energy that they need. If they do find it in less amounts, that's when we find cases like less bees, but not only that, especially honeybees. We're losing honeybees, they're weak, they don't find enough resources, right? And if you add the chemicals in other issues, that's when you see this in a more dramatic way. The interaction between the bees or pollinators in general and the plants are also a case of study. So that is called a network analysis. So the interaction network analysis is going to tell you, or it's going to tell us, what if we lose certain X, Y, or Z species? So, and we call that a chain reaction. So less plant diversity, less food source or resources, and then of course less pollinators. We're not going to talk about all the factors creating less plant diversity because we kind of understand where are we coming from, right? With all the factors creating that. Pollinator networks or plant pollinator networks can be really, really complex. So that's what we rely on certain analysis and softwares. But what I want you to learn today about this is that interaction networks can be disrupted. Of course, they're all the time disrupted. It's not going to be the end of the world, but certain species could could be more vulnerable to that. What species? The specialized species. So if a plant goes away, the specialist is very likely to go away too. And of course, we have lots of publications trying to explain or assessing the effect of, for example, grazing or deforestation and how we disrupt those interaction networks. We think about the proportion in general, that's what we have on the y-axis, the proportion of plants and the need of or the interaction with certain animal groups we have. In the first place, we have insect generalists. So a lot of plants, probably between 70 or 25% of plants in general depend of insects, are visited by insects. Then we have, of course, the bees, flies, and then a bunch of other groups. But let's see that general insects, bees, and flies are very, very important in plant systems in everywhere, pretty much. So in this is a little bit convoluted, but I will explain it. So the top part is saying that there's a kind of a cycle, right? And then it is here they're trying to demonstrate and show that we cannot rely on only one pollinator. This is kind of what I was talking about previously with the network. So if we disrupt the network, we will have less functionality in our system, and that brings a lot of consequences to us. In this case, this is towards crop pollination, crop yield, agricultural area, right? In natural areas within agricultural landscapes. So if we consider those factors, if we look at the pollinator community, that is where we typically have our major loss. And how's that? So when we change, that community is changed or degraded to a simpler community, we don't get enough flower visitation. And this is very complementary. So we cannot put all the responsibility on honeybees, for example, especially in agricultural or urban system, even though they are present no matter what, usually the plants need and rely on a bunch of other pollinators. So here in the lower part, the lower plot, it's showing the crop yield and the visitation rate. So the message is also simple. The more insects, right, the more diverse, the higher the crop yield. And this has been demonstrated in many different crops. This is in general, it's a summarized plot. So there's not a single orchard, right, or seed crop that doesn't need these pollinators to increase the yield. So here I want to show you that two different scenarios. I found this very interesting in this publication. So which landscape represents a higher risk for pollinators? So let's take a few seconds just to look at this. So on the left, letter A, we have this like little farm with a mix of natural habitat and small scale farming, right? Multiple plants and resources for pollinators. Then next to it, we have an intensively managed crop attractive to pollinators. It's not suitable for nesting. On letter B, on the right side, we have same mix, right? Of this habitat and multiple resources in the farm, and then we have in this case a crop field that is not attractive to pollinators. So we have these two scenarios. That is, I would say that can be considered a common situation in the PNW as well. So if we think about it, the letter A scenario implies a higher risk for pollinators because it is very attractive and it's very likely that farmers will spray. So I don't know if you're aware of that, but local farmers and growers can be really afraid of losing their crops sometimes, even though they're not really sure if they have a pest. So they rely on that is something that I call a non-IPM approach. So they will spray based on calendars. And that means that could be pretty wild. Could be a weekly basis or bi-weekly basis. They will spray because they don't want to see any single bug, touching their plants. And in some cases, this can be more problematic than others. But for example, potato seed growers would say, I don't want to see any single bug because it could be devastating, especially with aphids. But other crops will tolerate this more. The thing is that we don't really have information about the thresholds and those kind of things that are base knowledge that are not available. So thinking about urban landscapes, there is also a wild interaction and number of interactions between landscape factors and local factors. We cannot think about a city just as a big patch of concrete and buildings. We need to know that there's a scale influence. So, and they also interact. So I'm just putting some examples here in something called the urban heat island effect. So we have the landscape variation or heterogeneity, and then we have the fragmentation, surroundings, and then the heat factor, the impervious surface, right? Because we have a lot of pavement and nothing, we don't have any infiltration of water. And then also a number of local factors, the vegetation type, right? The size of each green space or patches, also called, and then of course microclimate. But urban landscapes can also be, or yeah, can be disruptive and can filter all urban, fauna as well. In this case, insects. So if you think about that like a mesh, we have a lot of specialists, and remember, I was talking about that specialist species. In this, let's talk about specialist bees. They will visit one plant species only, right? We have oligolectic that will visit one plant family only. So if we consider that we're in the urban environment with less resources, we're going to lose a lot of that. We have specialists, we have generalists, then small, big bees. Then we also have the time variation, the seasonal variation. We have early and late emerging species. We have ground nesters, cavity nesters. When they pass through that mesh, right, they're filtered, and we only get, you know, this typically the generalist species, right? Small body bees, late emerging species. We transform everything. We change all the conditions that you can think of. But there are processes to revert this. We'll talk about that. And I don't want to go too much into the agricultural part, side of things. But this one caught my attention. It came out recently. Let's see, I need to minimize my, there we go. So we have always the question in how much habitat do we need to keep our pollinators? So, I'll talk about the pollinator garden that we put at Parma this year, but um, for those of you who ever asked that, I mean, here's a recent publication, and it's also a meta-analysis evaluating how much habitat or like minimum requirements for conserving certain group of pollinators. And again, we could say, oh yeah, bingo, we got it. But there are thousands of species. We don't really know, we probably never know which ones are, the responses of each individual species. It's going to be really, really extremely difficult to know. And in this case, they are working with like functional groups or some taxa, right? Like you see here, like bumblebees, solitary bees, flies, butterflies, and tropical bees. And you see some groups have more studies than others. And also see the threshold where you can find the minimal, like semi-natural habitat, where you have a response, a positive response in the populations of these insects. So it varies also a lot. But it caught my attention that, for example, flies, in this case, sylphed flies, with only 5% of that habitat, their semi-natural habitat, they have a really, really high positive response in their population. That blew my mind. And then compared to the opposite side, we have the butterflies and the tropical bees, but this is only relying on 3 studies. So I'll say the butterflies. So that is also very interesting that they need way more semi-natural habitat to keep stable populations, and probably increase the number of individuals in those populations. But again, this is very general, and it's just giving us an idea of where should be our efforts put at to in especially in agricultural landscapes, which we have a lot in this region. So in the Pacific Northwest, I took different, Google Earth pictures and said, okay, what kind of landscapes do we have here? So we have, of course, heavily agricultural or crop or intensively crop managed landscapes. And of course, we have a lot of forest management. We have like more pristine forest. We have the city. We have really, really dry and flat land or grasslands as well. And I was like thinking about how many bee species we have. Some people are aware, some people are not. In the US, we have almost 4,000 native bee species. And in Idaho, we are still like in our infancy regarding our bee fauna. So we're working on something called the Idaho Bee Atlas. I don't know if you're aware of the Oregon Bee Atlas, the Washington Bee Atlas. So we are a little bit behind in that. And so far, the last inventory said that we got 700 over a little over 700 native bee species, whereas Utah has recorded way more than that, like more than 1,100 native bee species. Of course, Utah is known as a bee state, right? In this region as well, as many of you know, we have a lot of dependency on, we rely on pollinators, both wild and managed pollinators. And here's a number of crops that I'm just mentioning that that need pollination. It's not an option here. They need pollination, and it's conducted by insects, mainly by bees. So as an example, we have, I'm going to give you 3 examples. The alfalfa leaf cutting bee, the blue orchard bee, and we have the alkali bee. And of course, we have the honeybees who are, we rely on those also to pollinate crops, especially in California. I would say Utah, it's very similar case. But some growers have realized that when they combine leaf cutters, for example, leaf cutting bees with honeybees, they get higher yields. So they are very important in our economy. So if this $34 billion came out of an assessment back in 2012, so we don't know how that's changed, but it's a lot. So in Parma, we have, I oversee the Parma cocoon testing lab. So like I mentioned, the alfalfa seed growers rely on these bees. So back in the history, in the 50s, they realized the alkali bees were a blast for pollinating alfalfa seed. And that made a huge change in agriculture, I would say, in this region. But then like 10 years or in the 60s, 10 years later, they realized like we could actually use leaf cutting bees. They brought them from Europe and they got established here. The advantages were like they could propagate them easier. They don't need like long or large land extensions. So they could keep the alkali bees for a long time. They rather rely on this. So anyway, we are taking advantage of these pollinators, but also we're facing some issues. These bees are mainly raised in Canada, and that could be, an issue if we think about like some trade policies and also our need to keep buying Canadian bees because we get way more parasites here. So we really depend on them. That's not the best part of this. We've been doing some enclosures to evaluate pollinators, but I know the industry also uses those to produce higher yields, to get higher yields of carrot seed, onion seed, and vegetables. It is not widely propagated right now, but this is something going on. And then, of course, with the help of leaf-cutting bees, and some of them will use bumblebees as well in cages and enclosures, and of course in greenhouses. That's that's something undeniable that we need. This project is we started it last year. It was awarded, so we are assessing ways to propagate osmia, a blue orchard bee, in large enclosures. So my PhD, my master's student, Paige Rowland, has been working with the initial task and planting and evaluating, taking preliminary data on this. But we are pretty excited that we could do this project, especially considering the way that osmia bees are being propagated right now. They're pretty much taken from wildland, um, and we want to change that. Here's some tips that I would say, recommendations for helping our pollinators in urban habitats. So, I think right away a lot of people will relate on this, depending on what specialties or occupations we have in the audience today. But changing and converting our lawns, to a more pollinator-friendly habitat, it's the number one recommendation. And I think right now it's kind of a cliche or becoming a cliche, like, yeah, don't do that and change to bring some native plants. The reason behind it is not only that, it's that the amount of water that we are wasting there. I heard in the news one day when I was driving, um, that the US accounts nearly 8 billion gallons per day just for maintaining this landscape irrigation. That is wild. So I believe that should be something that other states adopt as well. Um, you know, the native plants, there's a number of resources for growing native plants, and not only for selecting the pollinator friendly, but also uh, you have to think about a floral succession. So you have blooming available throughout the season or for a long period. So you have to make a wise decision. And like I mentioned, there are lots of resources. And I think that's pretty good tailored uh, to multiple states or specific states. So I think that's something we can get easily, even from local nurseries, extension educators, and online resources. The Surface Society has been put at a lot of resources towards that as well. The USDA Lab, I know that they put some really nice guides for this. Here's an example. I mentioned that we put out a pollinator garden at the Parma Research and Extension Center this year, and it was really, really successful. At first I think I underestimated the 4,500 square feet that we put here, but we made it. Of course, it was a team effort, and we were able not only to put new plants, to put native plants there, but also I came up with the idea of testing like different ground covers. And I think uh, a number of people have realized that there's potential here for research. I thought about, the conventional or typical common practices that homeowners do, putting wood chip mulch and putting compost. And of course, if you look, I don't know if I can use there's no laser here, but if you look the picture on the right, you hopefully could see there's three ground covers. Well, actually two. There's a wood chip mulch, and then the black background there is compost, and then we have a no cover. We are seeing a lot of changes and responses, different responses. First, in the bee nesting, ground bee nesting, which is promising. Also in weed control. I think that's one of the biggest things that why we want to put mulching there. We don't want to carry any noxious weeds. We don't want to deal with it. We don't want to spray any chemicals. So the less work we put there, the less chemicals we put there, the better. And we're seeing very, very interesting results. So we're offering not only the flower resources, the pollen, the nectar, but we are also offering a habitat, inviting the bees, the pollinators to nest in our garden. And the other thing that we highlight with this project is you cannot see that in the picture, but we are surrounded literally by cropland. So it's only field crops, crop fields, and they are intensively managed. So this is a really, really good example of changing or an island effect. Changing a small change can make a big difference. Um, so before that, of course, this was a mess. You can see in the picture on the left, it was messy. It was only rocks, fabric. They put this landscape probably 20 years ago. The water wasn't even working, the irrigation wasn't working. So it was quite impressive to see all the change and the turnover in the community. It's just the beginning because we put it this year and we already saw multiple bee species, of course, wasps, flies, all the pollinators that I mentioned before, and even hummingbirds coming here. It was pretty impressive. So these are the changes that some examples we could do, and of course with the community supporting you, master gardeners are they really help us with this. Um, Probably I don't have to mention this too much because this is well known right now that it's kind of public knowledge, reducing the pesticides and herbicides use. I just want to mention that um, we have other options like biocontrol, right? And it's also probably well known. Uh, we have companies, right? We have some people delivering, even farmers adopting more and more these practices. They are avoiding and getting away from pesticides. It's not only something about conservation, but it's also profitable. They realize that organic crops are also good money, are profitable. So they're relying now on predatory mites, and are using they're releasing minute parted bugs, uh, parasitic wasps. There's a number of cases that I know now here, and I'll give you some. In this area, um, we have a couple companies that are using drones to release predatory mites. in hop yards. In Washington, I know they've been using that also in orchards. In California, they do it too. They're also releasing predatory mites in mint fields. That's something new, as far as I know, in this area. And of course, there's the soft chemistries. When I believe you've heard about the neem oil or any oil-based insecticide. These are the things that we could use to complement, but we need to understand what IPM is before taking actions on this. Both broad spectrum insecticides, as you know, are and fungicides. They could make the populations of bees and then pollinators decline pretty easy. So that's why changing the mindset towards more regenerative agriculture practices and more environmental friendly practices make a difference. And that is tied to this number 4 recommendation, which is counter negative perceptions of insects and educating people, basically. When we think about wasps, I've done this multiple times, and probably educators, if we have some educators in the audience today, will relate to this. When they try to talk about wasps, for example, to kids or homeowners, the first image that come to mind is paper wasps or hornets, yellow jackets, or and when they think about ants, they say when they think about bees, there's typically a negative perception. I mean, needless to say, when we talk about spiders, it's fear always. So it is very important, and that's our job to communicate to people and explain the biology and ecology of insects and the benefits of insect biodiversity and why we need to preserve that. These are two useful resources that I found, so we have a better understanding of how to enhance our urban and suburban landscapes. This one from Andoni, the one on the left from Melatopolis in Oregon. So it's the closest one I have here, and then we have another one from Michigan, but they pretty much overlap in many of the recommendations, and a lot of that we just learned about today. The current actions, and since I heard about giving a talk for Utah State University and people from Utah, I believe these are and these are the only two I heard about currently, but probably I'm wrong and there's more. These are two good resources, and a friend of mine told me that she applied for those and she got both of them. So one is the Utah Pollinator Habitat Program. So you will get plants, you get native plants. And then the other one comes from the Utah Water Savers, and this program is pretty much taking out all the grass, or at least a portion of it. And then for every square foot that you remove, and then of course you have to shift over drip irrigation. They give you, I think it's $2, but I could be wrong too. $2 per square foot. So you have to do the math, how much area you want to transform. And also, I think the landscape incentive program tells you that you have to plant some waterways or waterwise plants. So I think this is a win-win, and I'm kind of jealous that you guys have this in Utah. We don't have it in Idaho, but this was a good. This is an incentive also for me to start conversations with some friends and people to see if we could do something similar over here. So with that, I'll go just briefly with the take-home messages. The ones that I can think of right now, it's we have something that's called habitat loss. We are transforming the habitat in. Some people get shocked, that when they hear we already lost insect species. In the past, when I asked this, they said, "Oh, we're not going to lose insects; they're everywhere." But it's because we don't have enough information. Um, the climate change issues. Of course, since we saw the wildfire example only, I'm just stressing that out today. There's multiple other things that have been changing, the rainfall, patterns. Um, they are getting worse, and especially in this area. So there's not enough information about something like um, the smoke that we get. I saw a recent Western Serre project that is ongoing, and they're trying to see if honeybees, for example, get poisoned by this smoke when they take the pollen. I think that's a great thing to have to investigate. Um, we are disrupting pollinator systems because, of course, we have cities, we have farms. That's something we cannot stop, but we can change that. Um, education or extension education becomes critical for us to educate people. And then native plants are excellent resources. And I have a lot of examples that the plants that we put this year, I'm learning a lot too. We have the bee balm. We have a lot of blanket flowers. We have, a lot of salvias. I'm trying native mint. Something I forgot to mention real quick about the pollinator gardens. We're putting some things and plants that relate to the local industry. Some people say, "Oh, that's wise," because when they come here, we have the mint commission, we have the hops, we have dry beans, we have alfalfa, and they all feel like, "Oh, you're doing something, with the plants that we work with or the supplies that we use." And they support you. So that is the other thing that I think that's a good strategy for spreading the word and get some support. So with that, I think that's all, and I'm happy to take questions. I can stop
Um,
sharing now.
yeah, thanks, Armando. That was a good presentation, and I learned a lot about bees, which I thought I knew, but I didn't knew really. So I hope we all had the same experience. Uh, and with that, thank you everyone, and I will see you in the next webinar.
Thank you so much. Have a good one.
Thanks.